Lesson 12-3, Dividing Rational Expressions. And in this lesson, you learn to divide rational expressions. It is important because you can use rational expressions to solve problems involving constructions and railroads. Let's take a look at this example. In parades, a crowd watching the Tournament of Roses parade in Pasadena, California, fills the sidewalks along the route for about 5.5 miles on each side. Suppose these sidewalks are 10 feet wide and each person occupies an average of 4 square feet of space. To estimate the number of people along this part of the route, you can use dimensional analysis and the following expression. So you have 5.5 miles multiplied by 5,280 feet per mile times 10 feet, because that's the width of your sidewalk, and you divide that by 4 square feet per one person. This is the area covered by one person, and we will simplify this in example 4. If you recall, in 12-2, we used cars in a freeway, okay, a backed up freeway, to estimate the number of cars. In this case, we'll use people who are trying to watch the Tournament of Roses, or the Rose Parade. Okay, so before we answer that in example 4, let's go back to our basics. This division is similar to division of rational expressions. Recall that to divide rational numbers that are expressed by fractions, you multiply by the reciprocal of the divisor. Okay, you can use this same method to divide algebraic rational expressions. Basically, what it's saying, we're not reinventing the wheel in dividing rational numbers. We're simply following what we've learned in the past. Example, in this case, 3 over 2 divided by 2 over 5 is the same as 3 over 2 times 5 over 2. We are getting the reciprocal of 2 over 5 and multiplying to 5 over 2 with 3 over 2, and that will give us to our product, which is 15 over 4. In rational expressions, it does not change. So when you have a over b divided by c over d, we're simply getting the reciprocal of c over d and multiplying it with a over b. So this becomes ad all over bc. Okay, so knowing our basics, let's go to example 1. We want to find 2a all over a plus 3 divided by a plus 7 all over a plus 3. So first we copy the problem, and then we get the reciprocal of a plus 7 all over a plus 3, which is a over 3 over a plus 7, and then you multiply it now with 2a plus a over 3. Okay, and from there, okay, you can see that we can cross cancel. We can cross cancel the a, okay, plus 3. So you end up with 2a all over a plus 7. Okay, so sometimes the quotient of rational expressions involves divisor, that is a binomial. So now you have 2m plus 6 all over m plus 5 divided by m plus 3. Okay, we copy the problem, and we get the reciprocal of m plus 3 and multiply it by 2m plus 6 all over m plus 5. So this is now 2m plus 6 all over m plus 5 times 1 over m plus 3, which is the reciprocal. Okay, and we use the factoring method. If you notice, 2m plus 6 can be factored, and 2m plus 6 is just, let me make this thinner so it's easier for you to, it'll fit better. So if I factor 2m plus 6, okay, 2m plus 6 is, let me make this thinner again, 2 times the quantity, m plus 3. I factored out 2. Now I can cross cancel m plus 3, okay, and now have, which is exactly what happened here, cross cancel the m plus 3, and you now have 2 over m plus 5. Okay, and that's how we found 2m plus 6 all over m plus 5 divided by m plus 3. Okay, and sometimes you must factor before you can simplify a quotient or rational expressions, and that's what we have in example 3. You want to find x over x plus 2 divided by x squared all over x squared plus 5x plus 6. Therefore, we need to factor x squared plus 5x plus 6. Okay, copy the problem. Using method x, remember the coefficient of 1. Yeah, the product of 6, which will give you a sum of 5, will be x plus 3 and x plus 2. Okay. Before you do that, however, I forgot that you need to get the reciprocal of this one and multiply it by this expression. Okay, and then factor it. So you have x plus 2 plus x plus 3. Cancel out your x plus 2. Okay, cancel out your x. You're left with x, and you're simply left with now with x plus 3 all over x. Okay, secret word for this particular lesson would be Olympics. Secret word would be Olympics. And finally, let's go to example 4. Refer to the application at the beginning of the lesson. Estimate the number of people along the part of the parade route that is described. And this is what we were asked to solve. 5 plus 5.5 miles times 5,280 feet all over 1 mile times 10 feet divided by 4 square feet all over 1 person. So first get the reciprocal of 4 square feet all over 1 person and multiply it. So now we have the same expression except that we are now multiplying by 1 person all over 4 square feet. Okay, and then we start cross-canceling our units. Okay, miles, cancel that. Feet, cancel that. Okay, and what else can we cancel? That's it. Miles, feet, feet. Oh no, the feet and the feet will be feet squared. Therefore, it cancels that feet squared right there. So feet times feet, because remember this is 10 feet over 1. This is 5.5 miles over 1 as well. So feet times feet will be feet squared, and we simply cancel out the feet squared as well. So you're going to be left with the unit of people or persons. So we continue cross canceling. 5,280 feet crosses with 4, which is now 1, and this is 1,320. And then we simply multiply 5.5 times 1,320, end up with 72,600 people. So at the parade route, okay, there were around 72,600 people along each side. And since there are 2 sidewalks, there were 2 sides, the total number of people along the route was multiplied by 2, 72,600 by 2, which will give you 145,200. So in that particular stretch of 5.5 miles, there were roughly 145,200 people standing to watch the Rose Parade. Okay, and that's our lesson. Thanks for watching.